Hey, fellow problem solvers, Colfax Math here. The way you learn how to juggle, the way you get good at juggling is by practice. The way you do well on a standardized math test is practice. So we're going to do some practice problems today. I'd highly recommend you have a notebook and pencil out. You want to go through this video kind of slowly, pause the video, do the problem on your own or do the best you can. Unpause the video and watch how I solve it. There's going to be a lot of tips and tricks in here, especially with the multiple choice math exam. You could learn a lot more and a lot more practice tests. You could even get one-on-one tutoring. If you go to this webpage, there's an app on the Apple Store and also on Google Play. Highly recommend this app. Problem number 1. As I read this problem, I'm going to highlight that key point. Travels 3 hours at 50 miles per hour. Then slows down and goes 40 miles per hour for 7 hours. How many miles were driven in 10 hours? I look down here, all my answers are in miles, so there are no unit conversions. So if you do 50 miles in an hour, how many are you going to do in 3 hours? You're going to take that 50 miles per hour, multiply it by 3 to get 150 total miles. At this point, I'm going to look over there and look at my answers and see, well, I can eliminate that one for sure and probably the big one as well. So then let's take the next part. It's a total of 10 hours. I have gone 3 hours. I have to go 7 hours more at 40 miles per hour. So I go 40 times 7. 7 times 0 is 0. 7 times 4, 280. So the first 3 hours, I've gone a total of 150 miles. The next 7 hours, I've gone a total of 280 miles. What is the total number of miles in 10 hours? Well, 3 and 7 gives me that 10. So it's going to be this and this to give me my total mileage. I'm going to add those two numbers together, add straight down. 8 and 5 is 13. Carry the 1. 430 total miles. Answer A. Problem number 2, find the arithmetic mean of 4.5 and 9. It's kind of a vocab question. You need to know what arithmetic mean is. An arithmetic mean means the average. You add them together and divide by the number of values. But let's say you couldn't remember what arithmetic mean meant. I'm just going to look at my answers here and see that there are two answers that are pretty close to each other. The other ones are pretty big outliers. So I know I'm around 6. So if I know it's probably one of these two, I look up here and I can see that this together is 13.5. How am I going to get to 6? I know I'm going to have to divide by 2. So even if you can't remember what that word means, arithmetic mean, you could get some clues from those answers. So let's go ahead and do this problem. I have 9 plus 4.5. I add those together, that gives me 0.5. 9 and 4 is 13, so I have 13.5. I have 1, 2 values. So I take that 13.5 and I divide it by 2. 2 goes into 13 6 times. 2 times 6 is 12. 13 minus 12 is 1. That decimal point comes straight down. 2 goes into 1.5. Or 2 goes into 15 7 times. 2 times 7 is 14. I don't really have to keep going because I could look up there. There's only one value with a 6.7, so it has to be answer D. But if I were to keep going, 5 minus 4 is 1, bring down to 0. 2 goes into 10 5 times. Correct answer, answer D right there. If you're new to this channel, think about subscribing. It's all things math. And make sure you have that piece of paper and pencil in front of you. It'll only take you a minute to get up right now and grab some paper and pencil, pause the videos, do the problems before I do them. Let's keep going. All right, problem number 3, a circle has a radius of 3 inches. What is the area? Well, area of a circle is something you just gotta have to know. Area of a circle is this number right here, pi, represented with the Greek letter pi, pi radius squared. But let's say you didn't have that area in your head. You didn't know the equation for that. Again, I'm going to go to my answers, and I can see that they're all pretty well close to 28 except for this one. This one's an outlier. So I'm going to discard that one. Now if I had to guess, my chances go up from 1 in 4 to 1 in 3. And then if I had to guess, I would eliminate that one too. So then now my chances go up to a chance of getting it right just from guessing 1 out of 2 instead of 1 out of 4. And then now that I'm looking at these answers and I'm expecting something around 26, 27, maybe that'll jog your memory to go, how am I going to get from 3 to 27? Maybe it'll help you come up with that equation if it's somewhere in the recess of your mind. The only answer that works is 28.26. If it wasn't a multiple choice and you couldn't eliminate the other answers and know that's a little bit above 27, the way you would multiply it out is you take that 3.14 times that 9. 9 times 4, 36, carry the 3. 9 times 1, 9, plus 3, 12, carry the 1. 27, 28, and it would give me 28.26. But because it's a multiple choice answer, once you get to here, you could go right to the answers and solve it. Number 4, find the total thickness of 2 pieces of wood that a carpenter glued together. One is 5/16 and the other is 7/8. What is the total thickness? So I got to add these two fractions together, 5/16 and 7/8. Before I do anything, I'm going to glance down to my solutions and see if any of these make sense here. Well, I do know it's going to be more than 1, and all my answers are greater than 1. I can see it's a mixed number and a fraction, but that's about it. So let's go ahead and do this. When I add or subtract fractions, is the denominator has to be the same. Denominator is going to be that bottom number. So I got to get these two numbers to be the same. Well, if I just multiply this by 2, it would be a 16. But I can't just multiply this by 2. It's going to change the whole value of it. I could only multiply this by a factor of 1, so it doesn't change, right? Any number times 1 stays itself. So if I want to multiply that by a 2, I actually multiply by a 2 over 2. That's equal to 1. I don't change the value of it. But that gives me that 16 in the bottom. So now I have 5 over 16 plus 7 times 2, 14 over 8 times 2, 16. Now I have that bottom number the same. I have a common denominator. I add across the top 19, and I keep that bottom number there. So that's how I add fractions. It's kind of a tricky algorithm or process. I look over there, nothing's there, that's the same as that. So now I got to turn this into a mixed number. 16 goes into 19 one time. 19 minus 16 is 3. So 16 goes into 19 one time with the 3 left over. So it's 1 and 3/16. Correct answer, answer D, right here. Problem number 5, the area of a rectangle is 180. So I got this rectangle, total area is 180 inches, square inches, and the length is 20 inches. And I'm keeping track of my units here. What is the width? So this is the length, this is the width. So I know area of a rectangle is length times width. So 20 times what equals 180? Or 180 divided by 20 is equal to what? So I could see the answer is going to be 9 inches. And just a quick check on units. This is inches, inches, inches squared. So there's no unit conversion. Number 6, what is the area of a triangle? So I'm going to draw that out with a base of 8 and a height of 4. And again, I'm checking my units, 8 feet, 4 feet, check over here, square feet, no unit conversions. Once I translate this sentence into a picture, it's a lot easier. Problem number 7, if a circle, in a circle, what is the diameter in relation to the radius? Again, it's really kind of vocab. You need to know what a diameter is, distance all the way across the circle, and a radius, distance from the center to the outside. But let's say you can't remember those words. You look over here at your solutions. Well, they are equal. Well, how could they be equal if they're different words? So that doesn't even make sense. So I could eliminate that one. And then now I look up there, and there are 2 answers with a 2 in it. So it's probably got a 2 in it. So if I had to guess now, I'd guess between A and B. Again, my chances of getting it right now would be 1 and 2 instead of 1 and 4. Okay, so let's go ahead and do this problem. The diameter, again, is all the way across the circle. The radius is half that. So in a circle, what is the diameter to the radius? So the diameter to the radius is going to be all the way across divided by halfway across. Or let's say the diameter here would be 10. This would be 5. So the ratio would be 10 to 5 or 2 to 1. The radius were 5. 5 times 2 would give me the diameter of 10. Correct answer, answer B. Problem number 8, what is the sum? The word sum means to add of 1/6 and 1/7. So and is add as well. So again, this adding fractions, I have to have a common denominator. Before I proceed, I'm going to look at my answers here. Denominator 42, denominator 42, denominator 42 on D. And on 13 right here, that's so different, such an outlier, I know it can't be that. So if I had to guess, now I'm guessing out of 3 choices. But not only that, if I look at that 42 there, that tells me the common denominator, right? So how do I get to 42 here? I have to multiply 6 by 7 to get there. I can't just multiply by 7 because that's going to change the value of the whole thing. Again, I could only multiply by 1, so I got to multiply by 7 over 7. This fraction right here has the weight of 1, doesn't change the value of it, but it gives me that 42 in the denominator. 7 times 1 is 7. 7 times 6 is 42. How do I get this to be a 42? Remember the goal of adding fractions, same number on the bottom, equals denominators. Well, I got to multiply this by a 6. I can't just multiply this by 6. It'll change the whole value. I could only multiply by 1. So to make this 6 a 1, I put a 6 on top because 6 divided by 6 is 1. 1 times anything is what it already is, so it doesn't change the value. So I got 7 over 42 plus 6 over 42. I have that common denominator. I add across the top to get 13. Keep that denominator the same, 42. And I can see my correct answer is answer B right here. Adding fractions, again, is kind of complex, but if you think about it, like if I have a half plus a half, well, I know a half plus a half is going to equal a whole. So if I have this, I have that common denominator. I add across the top to get 2. I keep that 2, that denominator on the bottom 2. 2 over 2 is equal to 1. And that's what makes sense in my head, right? I got a half plus a half should equal 1. And that's how I could see this idea, getting that common denominator, adding across the top, keeping that denominator the same, makes sense. Problem number 9, if x minus 7 equals 83, then x is, this is just a quick algebra problem. Check your algebra skills. Again, if you don't know the answer to that, look at your answers. 2 of them are 90s. One's positive, negative. So if I had a guess, I'd guess between A and B. The way you solve this, you do whatever you want in an equation as long as you do it to both sides. So if I have x minus 7 equals 83, this is like a balance beam, right? So you just got to keep it balanced. You do whatever you want as long as you do it to both sides. If I add 7 to the left side, the advantage of doing that, that's going to give me x by itself because negative 7 plus 7 is 0. So now that I have x by itself, if I do that to the left, I do it to the right as well. 83 plus 7 is 90. Correct answer, answer B right here. And again, it's just a quick review of algebra. The key on this thing is you just keep this thing balanced. Number 10, 16 to 18. That's the same thing as a fraction. You could write it this way, 16 is to 18, or 16 is to 18 here. Again, I'll look at my solutions. Anything that doesn't really make sense, like 1 to 2 doesn't make sense because this would have to be 9 to 18 for it to be 1 to 2. So you're really just converting this to a fraction and reducing that fraction. Anything that'll go into either one, you want to divide by. So I know a 2 will go into each of them. 16 divided by 2 is 8. 18 divided by 2 is 9. That can't be reduced any further. Correct answer, answer C right there. Problem number 11, the square root of 25. So we have a square, which is a number times itself. 3 squared is 9. Square root reverses that. So the square root of 25 is saying what times itself is equal to 5. So what times itself is equal to 25? Only answer, answer D, 5. So again, this right here, 5 squared, is saying take that number, multiply it by itself to get 25. Square root of 25 is going backwards. What times itself equals that? And that's where that 5 comes from. This problem right here, number 12, is saying 12 is equal to x over 20. This is an algebra problem. Remember, I do whatever I want as long as I do it to both sides equally. So the goal is always to get x by itself. If I multiply this side by 20, 20 is the same thing as 20 over 1. 20 divided by 20 is equal to 1. So now I have x by itself. That's what I wanted. If I do that to the right side, I also have to do it to the left side. So I multiply 12 by 20. 2 times 12 is 24. Plus that 0, 240. Correct answer, answer C right there. Problem 13, another algebraic equation. So you've got to solve. No numbers in it. So this is a little more, conceptual. Solve for D. So that means I got to get that D by itself. So if B is equal to A times D, how do I get this thing by itself? Well, if this is multiplication, I reverse that with division. So I'm going to divide the right side by A. That and that'll cancel, giving me D by itself. If I do that to the right side, got to do it to the left side. So D is equal to B divided by A. B divided by A, answer A right there. Problem number 14, the value of 5, exclamation point. That doesn't mean 5. You don't have to yell 5. It's not an English thing. It's a math thing. And it's called a factorial. And what it does is if you have 5 factorial, the exclamation point is a factorial, it's going to be equal to 5 times the next number down, 4 times the next number down, 3 times the next number down, times 1. So you got to multiply it all the way down like that. You use that a lot in probability and statistics. Again, it's called a factorial. If you didn't know that, you look at your answers and there's really no giveaway on those answers. D doesn't make sense, so you cross that out. But then we're going to have to work with those 3 there. I mean, D doesn't make sense because why would you put the factorial out? So if you cross D out, then you could probably cross B out too because it would be an outlier of those 3. Then if you had to guess between A and C, your chances of getting it right if you just guess is 1 out of 2 instead of 1 out of 4. Let's multiply this out. 5 times 4, 20. 20 times 3, 60. 60 times 2, 120. 120 times 1, 120. Correct answer, answer C right there. All right, one more problem. Stick with me a little bit longer. Again, you got to do a lot of practice problems. The more you practice, the better you're going to get. If you like this channel, please subscribe, give it a thumbs up, and share it with anybody who might be standing for any standardized test, any standardized math test, because they're all pretty much the same, whether you're studying for the ASVAB or an SAT. The ideas, the tips and tricks, eliminating answers, all of that works pretty much the same. All right, last problem. Here we go. Number 15, 11 to the power of 3, or 11 cubed. What that means is 11 times 11 times 11. Got my red pen out here. So 11 times 11 is 121. I'm actually going to stop right there. Look at my answers. 121's there, but it's 11 cubed. It has to be more than that. It has to be 11 times 11 times 11. So 121 times 11, I don't know what it is, but it's got to be more than that. It's going to be 1331. Let me go to the white pen. Right? So 121 times 11, I could just finish right there, call it answer A. If you want to see how to multiply it out, 121 times 11. 1 times 1 is 1, times 2 times 1, placeholder, 1 times 1 times 2 times 1. I add all that up to get 1, 3, 3, 1. Correct answer, answer A. Again, I don't have to do all that long multiplication with a multiple choice test because I know it's going to be 11 times 11 times 11. 11 times 11 is 121. It's got to be greater than that. All right. Again, thank you for watching. If you have any questions, post them in the comments. I'll try and get to them as soon as I can.